Hi everyone. Today we are going to discuss a few of the new features which has been added in C++. So we will talk with reference to the C++ 14 and onwards. And these features are available in C++ 14 and C++ 17. So we will talk about these things today. New for loop format and the in-class initialization of the variables, default and final keywords, and explicit conversion operators. So I've opened two compilers. This compiler is the older one, even before C++11, and I have used one online compiler which has been provided by this URL, this www.onlinegdb.com. Right. So first I'm going to talk about the for loop which has been added newly. So in old format you cannot use this kind of for loop. This is a new format of the for loop which has been added in C++ 14 onwards. So if you have to iterate through an array, or you can say a sequence, then you need to use this for. Then you need to use this auto keyword. This auto keyword is not that auto where you define an automatic variable. This auto is something different. We will discuss that in future videos, but just remember that this auto is used. This auto has been used here just to tell that this a is a kind of variable where you can assign any type of value, right? So n array is the sequence from where the values will be one by one iterated through this through the entire array, and they will be assigned one by one to this a. They can be of any type. So you can, in short, you can understand that auto has been used to have any data type, just like a void pointer that can have any type of pointer in it, right? So if you write for auto a colon n r, this is the sequence, and then you just do a cout, and if you want to see the output, you just run it. This is the online compiler. This has all the features. You can see that here I have all the elements that have been printed out here, right? Similarly, it's not only for array. If you use a vector as well, you can see how it can be used with vectors. As include vector, and here I can use vector int v. I'm going to add few elements in it. V dot push underscore back 10, and then just copy it and add 3 or 4 more elements here. It didn't get copied. 2, 3, 4, 5 elements. This is 11, 12, 13, and then 15. So now if you have to iterate through it, just need to write auto, and then you just need to have this vector v here, v dot begin. Now let's see if it works. Okay, it shows me an error. Okay, don't need to use v dot begin. It's just v. It will automatically deduce the iterator, and through that iterator it will just keep iterating through it. So now you understood this for loop, how versatile it is, and how useful it could be while writing the code, right? How it can simplify the lines of code you can reduce in your program. Okay, so this was the for loop. There's nothing much. You have understood the basic idea, so I don't think there is much needed to work on this. You cannot do this thing in simple old compiler. If I copy this and I write it here, you will get an error. to F5. So you can see it's saying that there is a missing semicolon, comma before this colon, so it is not able to recognize because it's the old version of the compiler, right? So this one is done, new for loop. Now we'll move forward with the next feature, the in-class initialization, right? So suppose I write a class in the older version of the compiler, class my class, if I write int a is equal to 10, can I do this? Let's see if it compiles. It says 0 succeed. It says only static const integral data members can be initialized within a class. So it was static const int a is equal to 10, then only we could have initialized it. Now let's compile it. Then you can see that it will compile fine. It will not give you any error. Okay, you can see it succeeded, no errors, so we are fine with this. So this is the old version of the compiler, and we can see that in the older version of the compiler you can only initialize the static const variables inside a class directly, but if it's a simple variable you will always run with a compiler error, just like this. Okay, 0 succeeded, there is an error. But in case of new compiler version, that is the C++ 14 onwards, if you write something like this, class my class, and if we try to initialize this variable int a is equal to 10, this is C++ 17. You can choose C++ 14 as well and then run it. You will not see an error because it will compile fine, right? Program finished with exit code 0, no problems. So with new compiler version C++ 14 and C++ 17 onwards, C++ 14 onwards, it's fine. You can do the in-place initialization in the class. So this is the new feature which has been added in C++ 14 onwards. So next, move to the new one, default and final keywords. What are these? Let me show you something. Public, I have written my own constructor which will take one argument, and I'm just initializing it here. And let's compile it. This is the older version of the compiler, so let's see what happens. It's compiled successfully, but if I do, will it compile? No, it will complain. Because if we have provided one argument constructor, we must need to provide the 0 argument constructor as well. But if we don't want to give any implementation from our side, then in that case you can do one thing. With the new C++ version, you can just write it like this: public my class int a. I'm doing nothing here, and here also I'm going to do the same thing what I did there, m10, and then my class m1. Here also you will get an error with the new compiler as well, but if we write like this, default, then it works. So when you don't want that you have to provide any implementation of your zero argument constructor, but if you want in some situations that accidentally someone could create and someone can create using your APIs or using your classes, these zero argument constructors, you can create an object using these zero argument constructor, then in that case you can provide this declaration. But if we do the same thing here in the old versions, then it's not going to compile. Okay, so it says undeclared identifier. So this is the older version, but with the new version you can always compile it. Okay, so let's move to the next, the final keyword. Well, the final keyword says that nothing more can be done with this class or with this variable, with this function or with this class. If you make a function as final, suppose you make this function final, and if you derive one more class from your base class, then you will get an error. If you run this, marked final but is not virtual, you can see the message. This has been marked as final and this is not virtual. If it was virtual, then also we can't do overriding final function, right? So doesn't matter if it's a virtual function or not, you will not be able to override it in the derived classes. Okay, and what about the final keyword used with the classes? If I use the final keyword here, then what will happen? So you can see this is giving a message that you cannot derive a class from the my class, cannot derive from final, base, my class, in derived, type, derive. So you can use these final keywords in now in C++ 14 onwards to stop the inheritance or to stop overriding in case of the functions. And any extension of class will be seized if you use this final keyword. So this is all about the final keyword. You cannot use this final keyword with your old compiler versions. Sorry, I have to write it final. There is nothing like final, it cannot recognize it. It says final looks like a function definition, but there is no parameter list, skipping apparent body. So this is not possible with the older versions, but the new version provide you this feature. You can add the final keyword. What else left for today? Explicit conversion operators. Okay, let's do one thing. This is the last one for today. I write a function here, I write the constructor here. I'm writing int a, and here I'm going to declare one variable, int underscore a, and then here I'm going to provide underscore a, and here I'm going to write an implicit conversion operator int return A. So let's remove all the unnecessary code and let's see what happens. Okay, so I just need to correct it. I did some syntactical mistakes, but now it should compile. Okay, so if I do like this here, my class M, and I provide 10, right? So I have used this my class M10. So it will be this A will be initialized with value 10, and when I will do something like this, int A is equal to M, then A will be assigned a value of 10. Let's see what happens. Let's run it. You can see 10 has been printed here. I've used this int A is equal to M, and M did an implicit conversion to int, and then A was assigned with the value 10 because it was returning this value underscore A, right? The same can be done with the new classes, with the new version of the C++. Here I can also write the same thing. Let's copy the code. Let's remove this code. Then do this, and int A is equal to 10. Int A is equal to M. And then cout endl A. And now if you run this program, you will be able to again see, okay, what is this? Okay, it's private basically. I need to make it public. Now it will work fine, and 10 will be printed because A will be assigned a value of 10 because of this conversion operator. It will convert the value to, it will return a value of underscore A. So these operators are the implicit conversion operators. Okay, so with the C++14, what is new? The new thing is the explicit keyword. Earlier, you could have used this explicit keyword with the compilers, with the constructors only, but with the C++14 onwards, if you compile the C++14 as well, then you can see that this explicit keyword has been used with this operator, implicit conversion operator. It is allowed now, C++14 onwards. And here you can see the error message, cannot convert my class to int in initialization, because this explicit keyword says that if you have to assign, if you have to take the conversion, if you have to get the converted value, then you must need to explicitly provide the typecasting. So if I do this, then this will work. Now it will work. So this was done basically to avoid the accidental conversions, right? So that was the only thing because of which this was added in C++14 onwards. In C++17 as well, it will be there because it's in C++14. So C++17 will also be compiling. Okay, so I think everything done for today. If I do like this explicit operator end, then let's see what happens. You can see that it is giving me an error with the old compiler version, illegal storage class. So with the older ones, the explicit conversions of the operator was not allowed, but now with the C++ 14 onwards, you can do this. Okay, so thanks everyone, and that's it for today.